Okay guys, let's take a look at today's lesson. It's 12.5b, rotation of conics. This is day 2. So we have one lesson under our belt for rotation of conics. We're going to take it a little bit farther today. This is just a reminder of what the general second degree equation for conics looks like, because we're going to be using these variables, the a, b, c, d, etc., in our formulas right here. So these formulas you will have to know. You would have to memorize those. We are not having you memorize the formulas that we did last time, but these you would need to know. We're not going to provide those. So if we actually can take the equation, and as long as it's not a degenerate, we can determine what type of conic it is. And that's a key. If it's degenerate, then this test doesn't work. It doesn't work if it's a degenerate conic. But if it's not, and usually they're not going to give you one that's a degenerate because the test doesn't work. What you can do to determine the type of conic that you have is use this little formula, b squared minus 4ac. Now note that b is the coefficient of the xy term. And so when we calculate these, we need to make sure it just works with the xy terms. It's kind of a little different formula than what we're used to. When it's in normal form, we actually just look at it, and if there's a plus, we know it's either an ellipse. There's two squareds and a plus, we know it's an ellipse. But this case is a little bit different. All right, so let's take a look at the next formula. And what this formula does is, this is the addition that we're adding today from the last notes from Friday. This formula allows us to find phi if they don't give us phi. On the lesson from last time, you would have an equation, comma, and then it would give you the phi value, like 45 degrees, that homework problem we just looked at, or arc sine of 3/5, something like that. Well, there will be times when they don't give it to us, and we have to calculate it. And that's what we use this formula for. It's tangent 2 phi equals b, which would be the coefficient of the xy term over a minus c, the coefficient of the x squared term minus the coefficient of the y squared term. Okay, and we're going to use that formula today. All right, so let's take a look. The first example is just using this technique right here, trying to determine whether we have an ellipse, circle, parabola, or hyperbola. They're asking us to use the discriminant. This is how it would be worded on a quiz or a test. It would say use the discriminant to identify, and that would be what we'd be looking for. So let's do that. We need b squared minus 4ac. So our b is this one. So 96 squared minus 4 times a is 64 and b is 36. Somebody have a calculator out there? All right, so what do we have? 96 squared, what is that? 1216? 92. 9216. And then 4 times 64 times 36. Is it the same? Wow. Gigantic numbers. Okay, so it's 0, so that means that we have a parabola here. And that's how you use the formula. You just plug into the formula, do your calculations, and then determine what type of conic it is by what the result. Whether it's equal to 0, less than 0, or greater than 0. Okay? All right, let's look at our next one. This one is similar to the last lesson, except that we're not going to have an xy term in it when we're done. We're going to actually be able to sketch this graph. So we're going to use the formulas from last time. Let me write them up here. And let's work through trying to figure out which one we're supposed to use. Okay, so that's our two sets of formulas, which we've talked about. You're not going to have to memorize those. You just have to know how to use them. We have an equation. Remember from last time, if we have an equation that has little x's and little y's, we actually want to use these, right, so that we can replace the little x's and y's with big x's and big y's. So we're actually going to use those types. Okay? But when we have points, we use these bottom ones. Remember that from your homework? We use the bottom ones with points, but with equations, we're going to use these two. So let's go through and let's find the values of these equations. I'll just write it down here for room. So little x is going to be big X, cosine of phi. Phi is 45, so cosine 45 degrees minus y sine of 45 degrees. Let's finish that little x one out. So cosine 45 degrees is root 2 over 2. And sine 45 degrees is also root 2 over 2. Okay, there's our representation for little x. Now let's get little y. So it is sine of phi, which is 45 degrees, plus y cosine of phi. And working that out, little y is going to be root 2 over 2 plus root 2 over 2y. Okay, just like the lesson from Friday. So let's take those and let's substitute it in our equation that we're given right here. So little x is okay, that's our representation for little x. Little y is going to be root 2 over 2 plus root 2 over 2, and that's going to equal 2. Alright, so let's FOIL these and combine like terms. Let's see if we can get it to look like a normal conic that we are familiar with. So let's do that. So root 2 over 2 times root 2 over 2 is what, 2/4. I'm just going to leave the fourth there. We talked about that last time. If you start simplifying, it's probably just going to make your life harder. So just leave the 4 there and we'll fix it up later. The nice thing about this one, look, it's outside inside. What's going to happen to outside inside? Yeah, they're going to cancel. Isn't that great? So basically 2, and I'll go ahead and write it out just so we have record of it. So it would be 2/4 big X big Y minus 2/4 big X big Y. They're going to just go away. And then plus 2/4 y squared equals 2. Okay, those cross. Oh yeah, this one, minus. So cross those out, we're left with, and since we don't have anything to combine together, we can go ahead and reduce that fraction. It's just 1/2 big X squared minus 1/2 big Y squared equals 2. So that is going to represent some kind of a conic. Hopefully we kind of recognize it. What is that going to be? It's going to be a hyperbola, isn't it? And so we need it in proper hyperbola form. And to be in proper hyperbola form, this needs to be a 1. So I basically need to multiply through by 1/2. So I'm going to have, it's basically 1/4 and 1/4. I'm going to write it a bit differently, just how we're used to seeing it, actually in standard form. And that gives me my hyperbola. Now, for the graphing. What I do is I draw a regular set of coordinate axes. Then I look and see what the phi is. My rotation is 45 degrees. So I'm going to draw a dotted line axis with a 45-degree rotation. And we rotate from X, our normal rotation. So I'm actually going to have my rotated axes are going to look like this. And what I do is I just turn my paper. I just turn my paper and graph it on the dotted line axes. It's just the easiest thing to do. Now I can't turn the board, so I'm going to have to kind of go like this. But we just need to graph this conic on our dotted line axes. With now this portion is going to be our big X, and this is our big Y. Okay, does that make sense? This would be like our positive, this would be like our first quadrant in our rotated form. And so my hyperbola would have a center of 0. And let's see, it would go out 2 spaces each way. So and you don't have to put the lines on here. It might even be too confusing. You can just put your little marks on your dotted axes. So let's see, we go out 2 spaces each way, and we draw our little box. We would actually have our asymptotes this way. It's going to get kind of confusing with all the dotted lines, so actually I'll just change color. So our asymptotes would go through the corners of the boxes. And let's see, we have the X one is first, so it's going to be horizontal. So it's going to be this part right here. And that's our graph. That's a rotated graph. It's just like a regular graph. We just draw dotted line axes, shift our paper, and then graph on that. Okay? Is that okay? Okay. Last problem. I need a little bit of room, so is everybody done with this? Okay. All right. Eliminate the XY term and sketch the graph. Now, on your notes, if you have notes printed out, we accidentally put the phi on there already. So just kind of ignore that. We have to teach you how to find the phi if you don't have it. And that is referring to the formula up top. Let's write it down. Tangent to phi equals b over a minus c. Okay. So this problem is going to turn into a problem just like I did, that one that I just finished, but we have to find the phi first. That's all. We have to find the phi. And so let's do that. Let's read this information off of our problem. So I have tangent to phi equals, b would be 2, a is 1, and c is 1. So I get tangent to phi equals 2 over 0. Okay. Now, one thing that I didn't mention when we were talking about the formula up front, at the top, is that these need to be principal values. Remember back to last semester, principal values. You can't just pick any value you want. It needs to be a principal value. And so the principal value for tangent, where tangent is undefined, because 2 over 0 means it's undefined, right? That's where tangent is undefined, is pi over 2. Right, that's the first location that tangent is undefined, starting at an angle measure of 0. So if you remember our technique from last semester, when we're solving something like this, we kind of cover up the 2 phi. We say, where is tangent undefined? And we say, oh, that's pi over 2. Then we say 2 phi equals pi over 2 and solve for phi. So for this particular problem, phi is going to be, I would multiply both sides by 1/2. Phi would be pi over 4, which if you have the notes printed out, you already know. But that's how you would find it. It's not like a made up, I can't just take an equation and make up a phi. It actually is generated from the equation. The way that the equation is written will generate the proper angle measure. Does that make sense? And sometimes they're not unit circle values. For us, for our purposes on quizzes and tests, you know, if it's on the non-calc part, it's going to be a unit circle value. It's not going to be something that you can't do. All right, so let's work on that now. We have our phi, and I'll write our little formulas up here again. Okay, so let's use those. Oh, this one's going to be quite an intense one, isn't it? Oh, look at all those x's and y's we get to play with. Woo! It's going to be great. All right, so let's find our representation for little x, little y. So little x is big X cosine pi over 4 minus big Y sine of pi over 4, which is, what cosine pi over 4 is root 2 over 2. Looks very similar to the just one that we just did, doesn't it? Because, of course, it's the same pi over 4. So that's our little x. Little y, I'm running out of room, I'll put it over here. Little y is x sine pi over 4 plus y cosine pi over 4. So it is root 2 over 2x plus root 2 over 2y. Well, hopefully this, with positives, minuses, that will help us out a bit. But hope you have a lot of room on your paper. See why we didn't give you like 25 of these for homework? Wouldn't that have been crazy? It's like, I don't know, it's just a handful. So let's take our little x and let's sub it in here. Root 2 over 2 big X minus root 2 over 2 big Y squared plus 2 times. Put the little x guy in there again. And multiply it by the y one, which is root 2 over 2x plus root 2 over 2y, plus, put the y one in there, and that is root 2 over 2 root 2 over 2x plus root 2 over 2y. And that one's squared, plus the x one. I'm going to put them in parentheses. It's not necessary, but it's just going to help me partition them off. And then the y one. Whew. Okay. Let's see what's going on. So here, notice how I'm just trying to kind of lighten our load a little bit. Notice how we have root 2 over 2x minus root 2 over 2x. Those are going to go. And we're just going to be left with, on this end, with a minus. See how the minus 2 of these. And we'll get with that to that in just a minute. Alright, so let's start foiling. I'm real visual, so I would like have scratch paper out on the side, and I would like put on my scratch paper this so I can look at it when I'm working with it, just so I don't miss something. I would just do that like on scratch paper, but I'd write it underneath here. So that's going to give me 2/4 x squared. And then the outside would be 2/4 would be a minus 2/4 xy. Inside a minus 2/4 xy. And outside of our last plus 2/4 y squared. Okay, and I'm leaving them in fourths because I'm going to have to combine them together. It should be easier for me. Alright, so 2, we're going to distribute that in a moment. So first times first here would be 2/4 x squared. Outside, inside go away. So minus 2/4 y squared. So that's what we're left with that. Here, again, I would want to draw that out. I'd want to write it on scratch paper so I can look at it. Root 2 over 2x plus root 2 over 2y. Root 2 over 2x plus root 2 over 2y. So that would give me 2/4 x squared plus 2/4 xy plus 2/4 xy plus 2/4 y squared. And then we have these guys right here, minus, let's see, I'll just write it like that, minus root 2 over 2y minus root 2 over 2y. Okay. So the xy's, if we've done it properly, if we've found our angle properly and we've done this properly, the xy's should just evaporate. And if you can see, I have a minus 2/4 xy minus 2/4 xy plus 2/4 xy plus 2/4. They're gone. If they don't disappear, then you need to know that's a great check right there, an algebra check. You know that you've made some kind of an algebra error if they don't go away. And now it's just combining like terms. Let's see what we have going on. Let's do the x squareds first. So I have 2/4 x squared. I have that x squared, that one. So this one gives me 4/4. So 2/4 plus 4/4 plus 2/4. How many does that give me? 8/4, which is 2. So 2x squareds. So x squareds are goodbye. Okay? So let's look at the y squareds. I have a 2/4 y squared. I got that y squared and that one. Let's see. So this one, I have 2/4 y squared minus 4/4 plus 2/4. What is that going to give me? They're gone, aren't they? They're gone. So, sorry, y squareds. You're gone. Alright. What do we have left? We have, let's see, we took care of all of that. Looks like we just have these guys left. So, if I add these together, I get minus 2 root 2 over 2, which is just, right, it's just root 2. So minus root 2y equals 0. Okay, that's a lot of crazy algebra. Y'all checking my work? Are we okay? Okay. So what kind of conic is that? It's a parabola. We just need to, it does ask us to graph it. We just need to get it in parabola form and graph it. So, which we had some issues with on the quiz, is getting it in parabola form. Alright, so let's do that. We'd move that over. I'd have 2x squared equals root 2y. So I need y to have no coefficient in front of it. So I would divide by root 2. So I get y equals 2 over root 2x squared. Now you can rationalize it if you want to. What would that be? Root 2 over 2. I'll just do scratch work over here. So what? 2 over root 2 times root 2 over root 2. 2 root 2 over 2. So that just gives me root 2. So y equals root 2x squared. Alright, so let's graph it. I'll just wedge it right up here. Our phi is 45 degrees, so we still have those guys going on. My center is at 0. Let's see, it's going to go up. And so it's going to look something like that. If we wanted to find our focus and etc., we could. But this is pretty complex. We're actually not going to go that far. We're just going to sketch it. Okay? There we go.